Hi and good day, everyone. Um, how are you? I hope you can spare some time to watch this lecture, amid the chaos of COVID-19 around us. Again, Ramadan Kareem to all Muslim students, and may this Ramadan brings you closer to Allah than ever before. So today, I would like to dive into the introduction of automation in manufacturing, as promised in the teaching plan. Okay, so there are a few agenda at hand. Firstly, we will delve into the production system and why do we need automation in manufacturing. Then we will examine automation principles and strategies in manufacturing system and how to use them to automate the manufacturing. Then we will look at how automated manufacturing system can be established, and then how automation affects the manufacturing industries and what kind of automation work cell is feasible to be set up for each production system. Finally, we will look at the overview of computer integrated manufacturing as a practical idea to evolve the manufacturing system into a smart manufacturing as a prerequisite to the current establishment of cyber physical system. Now, if we Google the term automation, it points out that automation is the technology which requires minimal human assistance. In other words, we are going to ensure processes can be run with as few human participation as possible. So in principle, automation is a process following a predetermined sequence of operation with little or no human labor, using specialized equipment and devices that perform and control manufacturing processes. So to be able to do that, the minimum human intervention, we need a variety of devices, sensors, actuators, techniques, and equipments that are capable to do three things. Three things that ensure automation can be done is observing the manufacturing process, making decisions concerning the changes that need to be made in the operation, and controlling all aspects of it. Okay, so if we try to remove human from the process, or basically limit the human intervention in the process, the automation process itself must be able to do these things. Okay, there's three important things. It must be able to observe, it must be able to make decisions if there is something wrong happen to the process, or if there is some changes that need to be made, and it should be able to control all aspects of the automation. Now, automation was the key concept adapted in the third industrial revolution. So as you can see in this diagram, we are now in the era of fourth industrial revolution, in which automation now becomes ubiquitous. And instead of focusing on simply automating the production, it evolves into a cyber-physical system in which customization can be done on the fly with optimized decision-making in place. We can also see from this diagram that the degree of complexity in production system becomes higher as we move from the first industrial revolution, which only focuses on replacing human power with steam power, to a myriad of devices working together with optimized decision making. Before we delve further into that, we'll first see what comprises the production system and how the automation fit in. Okay, a production system is a collection of people, equipment, and procedures organized to perform the manufacturing operations of a company. It can be divided into facilities and manufacturing support system. Facilities typically refers to factory, equipment in the factory, and the way they were organized. Manufacturing support system, on the other hand, is a set of procedures used by the company to manage the production and solve technical and logistic problems. So in modern manufacturing systems, or in modern manufacturing operations, portions of production systems can be manually done, automated, or computerized. This means that people are also part of the production system. Direct labor people are the ones operating the facilities, and the professional staff handles the task to support the manufacturing system. There are three basic categories that outlines human participations in manufacturing, which are manual work systems, worker machine systems, and automated systems. A manual work system consists of one or more workers performing one or more tasks without the aid of powered tools. An example of such system is a machinist using a file to round the edges of rectangular workpiece after milling. And we can see this in a lot of production that are very much customized, in which the machines to provide such customization is very difficult to make, and probably have a larger or have a small ROIs in purchasing them. So a lot of workers are still doing it manually. So this is what we call a manual work system, in which a lot of work in the production system are manual. In a worker machine system, a human worker operates powered equipment such as machine tool or other production machines. And we can see this, for example, in a lot of production lines in the world, where you have operators that do the screwing and the assembling instead of a fully automated machine. So the assembly is using, for example, a powered screwdriver, or even with the help of a robot, but was guided by a worker. So this is an example of a worker machine system, and this is the category of production system which are widespread all over the world. The third category is automated system. So this is a process that is performed by a machine without direct participation of human worker. There's not always clear distinction between worker machine system and automated system, because many worker machine system works with some degree of automation. Typically, there are two levels of automation in production system, which are semi-automated and fully automated system. So semi-automated machine performs a portion of the work cycle with some program control, and human worker tends to the machine for the remainder of the cycle, such as loading or unloading. A fully automated machine can operate with an extended period of time without human attention, which means multiple cycles of the process can go through automatically. Such operation can be seen in injection molding facilities, in which periodically molded parts must be collected by the worker. In a certain fully automated process, a worker is needed to fully monitor the process. They were not actively participating in the process except for making a few adjustments if needed according to intended specifications.